So if we take a look at this lab, we have 4 formulas. We have 2 that we can use for angular velocity because we have this one where we have radians over time, but we also have this one where we could get omega by itself and have this. So we have those 2 formulas that we could use. We also have 2 formulas that we can use for linear velocity. So those are the 2 things that we're using. And then this one is for your arc length. So that's what we have on this slab. So if we look at the first one, it says if the arc length of a circle is 10 yards, the radius is 11 yards, find the angle measure in radians. So here's our formula for arc length. We have arc length is 10 yards. They're both in the same unit, so we don't need to do any kind of conversion. Our radius is 11 yards, and we're looking for theta. And remember that in this formula, theta is in radians. So if I do a little bit of algebra and I round a little bit, I will get theta is roughly and I'll put the little squiggly lines, 0.91, and that is in radians. So that answer is in radians. Okay, number 2. If the arc length of a circle is 6 feet, the angle measure is 30 degrees, find the radius in feet. So again, here's our formula. And remember that theta is in radians. In our problem, they give it to us in degrees. And you can do a conversion, or you can look at your unit circle, but 30 degrees is pi over 6 radians. So if I put my arc length of 6 feet in there, my don't know my radius, so if I leave that alone and I put pi over 6 for my radians, and I do my math by dividing both sides by pi over 6, radius is going to be 36 over pi, so roughly radius is going to be 11.46 feet. So there's that one. Some of you missed it because you did not change the 30 degrees to radians. Number 3. If the radius of a circle is 2.3 centimeters, the angle measure is 7 pi over 12. And again, if it's 7 pi over 12, it's understood to be in radians. Find the arc length. So here's your formula. We have everything we need to plug in. The radius is 2.3 centimeters. Theta is 7 pi over 12. All I need to do is take my calculator and multiply 2.3 times 7 pi over 12, and I get roughly 4.21 centimeters. Let's go ahead and do numbers 4 and 5 in this video. Number 4 says if the arc length of a circle is 33 meters, the angle measure is 6.4 radians, find the radius of the circle. Same formula, S equals R theta. We have the arc length of 33 meters. We know the angle measure is in radians, so we're going to substitute that in. Again, divide 33 divided by 6.4. Our radius is roughly 5.16 meters. And the last one for this video is a bicycle wheel rotates 70 times in 1 minute. So when you're looking at this one, you have to determine what they've actually given you. And anytime they tell you whether it's degrees, whether it's radians, whether it's how many times it rotates, revolutions, any of that, if it's out of time, they have given you angular velocity. It's just that the standard for the formula, the theta must be in radians. So if they've given it to you and they want it in revolutions per time, then you could convert it easily. You would just need to know those conversions. You know that if you're talking about revolutions, 1 revolution around the circle is all the way around, so that's 2 pi radians, that's 360 degrees. You can make those conversions. And in fact, in this one, it asks you to do degrees. And it's talking about 11 seconds. So we've got our rotation, it rotates 70 times in 1 minute. So we know that the angular velocity that they have given us is 70 revolutions or rotations in 1 minute. and they want us to have degrees, and they're talking about seconds. Now, once we get it per 1 second, we can multiply that answer by 11 for 11 seconds. But for this one, we need to be able to make a conversion. We could do some dimensional analysis, and when you cancel things out with fractions, if something's on the top and you want it to cancel, you'll need to put it on the bottom to make it cancel. And since we have revolutions or rotations and we want degrees, we need to know that one rotation around the circle is 360 degrees. So one revolution or rotation is 360 degrees. So that makes the revolution or rotations cancel, and I'm left with degrees. And I'm left right now with degrees per minute. So that's what I have right now is degrees per minute. And I don't want minutes, I want seconds. So what I know about that is that 1 minute, and again, minutes are on the bottom, and I want to make it cancel, so I'm going to put it on the top, is 60 seconds. So now I have degrees and seconds, and if I do my math on that one, 70 times 360 divided by 60 seconds comes out to 420 degrees per second. That's for 1 second. So if I want it for 11 seconds, I would just need to multiply it by 11, and I would get 4620 degrees for those 11 seconds.